Nuclear fusion is the process that powers the Sun and other stars, providing the energy that makes life on Earth possible. It involves the merging of two lighter atomic nuclei, typically isotopes of hydrogen, to form a heavier nucleus such as helium. This fusion releases a tremendous amount of energy, far more than what is produced by nuclear fission, the process used in current nuclear power plants. So how does it work? It's all about smashing atoms together. In a typical fusion reaction, two hydrogen isotopes, deuterium and tritium, are fused together under extremely high temperatures and pressures. These conditions are necessary because atomic nuclei naturally repel each other due to their positive charges. However, when the temperature reaches millions of degrees, the kinetic energy of the particles is so high that they can overcome this repulsion, allowing the nuclei to come close enough to fuse. When deuterium and tritium nuclei fuse, they form a helium nucleus and a neutron, releasing a significant amount of energy in the process. This energy is primarily in the form of kinetic energy of the particles and can be harnessed to produce electricity. While nuclear fusion promises nearly limitless and clean energy, it is incredibly challenging to achieve on Earth. The main difficulties lie in creating and maintaining the extreme conditions needed for fusion, temperatures of millions of degrees and pressures found in the core of stars. So far, these conditions have only been sustained for very short periods in experimental reactors. One of the most advanced approaches to achieving fusion is using a device called a tokamak. A tokamak is a donut-shaped chamber that uses powerful magnetic fields to confine the hot plasma, a state of matter similar to gas but with charged particles, necessary for fusion. Although practical, large-scale nuclear fusion power remains in the experimental stage, significant progress is being made. Projects like the International Thermonuclear Experimental Reactor, ITER, in France are working to demonstrate the feasibility of fusion as a viable energy source. If successful, fusion could provide a nearly inexhaustible, clean and safe source of energy, reducing our reliance on fossil fuels and addressing climate change.